All right, well, we're going to put all of these different things that we have learned together in 7.6. Uh, I gave you some notes over here on the side, things that you're going to want to remember that we've talked about in previous lessons. The two forms of this function. So you've got your logarithmic form and you have your exponential form. So we need to remember both of those because we're going to have to be able to go back and forth between them. The three properties of logarithms, and you can see your property for multiplication, division, and then when we have there in number 3, when you have your m raised to an exponent. And then over there in the green, I gave you some steps to follow to solve these until you become accustomed to it. The first thing we're going to want to do is isolate our exponential expressions. So if you look over at the worksheet, it says to solve the exponential equation, they want you to round the result to 3 decimal places. So we talked about doing that with these, and so we'll just need to remember to round to 3 decimal places instead of 2. So all of these problems we're going to work are in exponential notation. So they're in the form over here to the side, and we're going to need to be able to take that into the logarithmic form to solve these. So the first thing we want to do is isolate that actual expression. At number 1, it's already isolated. Same thing with 4. Number 7 is already isolated. The first one we get to is number 10. Number 10 has this exponential expression right here, 3e to the x, but we have a 7 being added to it, and it's also itself being multiplied by 3. So we'll have to take care of both of those things before we can go any further with that. And so we're just going to start up at number 1 and start solving down through some of these steps. So number 1, like we said, step 1 is already done. It's isolated. This one is a little bit easier than some of the other ones we're going to do because we know that anything, any exponential expression that's going to equal 1, the only way to get that is to actually have that exponential expression raised to the 0 exponent. So on number 1, the only answer here that's going to work is having e raised to the 0 power, because e raised to the 0 power will equal 1, because anything raised to the 0 power will be 1. So in this case, to solve that exponential equation, our x would need to be 0. On number 4, the step 1 is taken care of. The exponential expression is by itself. So we'll move down to 2 and check the bases on these two. The bases don't match, and so because of that, we're going to go ahead and rewrite this either to make the bases match, that's what number 2 says, or if we can't rewrite the bases to make them match, then we're going to write this out in logarithmic form. So we can see pretty clearly on number 4 that there's no way to rewrite a 5 and a 12 to make them have the same base. So we're just going to go ahead and rewrite in logarithmic form. So that would be using our form up here. We'll call it log. Our base is going to be that 5 because that's our b. Of 12 equals x. And so if you're having trouble identifying where each of those numbers goes, you can just rewrite like we did in the previous lesson. You can write the form underneath the original problem, and then it becomes a little easier to see that your b is 5 and your y is 12. And it kind of helps you then to move the numbers around correctly to get it into logarithmic form. All right, so that's why my base here is 5. I set and I put in 12 for y, and we're saying that whole thing equal to x. So I'm just following the form and taking it from exponential to logarithmic. So now I have x, but I need to use that change of base formula, okay, which is down here in number 5. So we went through number 4, we isolated x. X is all by itself now. Now we're going to use the change of base formula to rewrite this into a logarithm that we can actually put into the calculator. So remember, to use the calculator, we either need to have a base of 10 or a base of e. And so we're going to use base of 10 when we're practicing these, but we could also use base of e, and sometimes they'll use base of e in the textbook as well. So we're going to take this form right here, and we're going to use that as a change of base. So our base is always going to be 10. So I'm going to write log. I'm not going to write the 10 in down here because it's assumed, because we're using this formula. And you can see that I need to take my a value, which is 12 in this case, and then I'm going to put that over the log of my c value, which is 12, which is 5 here. And I realized just now as I was doing that, that I left the a out right here in the formula down here for the change of base formula. So make sure you stick that little a in there. That's important, because that's how we're knowing, that's how I knew to put the 12. The 12 is my a up here in my logarithmic function form, and so that's how I knew to put it here in the numerator. All right, so here from this point, we can plug this into the calculator, because now we have it in base 10, so we're able to plug it into a calculator and have it come out accurately. All right, so once you have your calculator, you're going to hit log, and then put your 12 in, and parentheses, divide by your log of 5. And that's what you should come up with, 1.54. 1.544 actually, because we're going to round to the nearest thousandth place. All right, so that would be 1.544. All right, moving down to number 7, and following our rules, we can see again that our exponential expression is isolated. We have e raised to that 2x. And so then we're going to check to see if we have the same base. We obviously don't have the same base. We have a base of e over here, and we don't have that on the other side, on the right side. So we're going to need to either rewrite to have the bases match, which isn't going to be possible here. And so since we can't do that, we're going to move down to number 3, and we're going to write this out in our logarithmic form. Okay, so once again, we're going from exponential form to logarithmic form. All right, so when we do that, it'll look like the log base e 4 equals 2x. Again, if you're having trouble seeing that, just come over underneath the original problem and write in the b to the x equals y form, and then from there you can navigate to the logarithmic form a little bit easier. Now, one thing I want to point out here is that whenever we have a log with the base of e, if the base is e on the log, that is actually the natural logarithm, and that's when we can use the ln button on our calculator. So I can just replace that log base e with ln, and so it would be ln 4 equals 2x. So now when we go to plug this into the calculator, you'll see we're going to use the ln button instead. So let's move down through the steps again. That was number 3. Now we're in number 4. We have to isolate x, and this is just a simple division. All right, and now we have x isolated. We don't need to use change of base formula here because we're dealing with it's already in base e, a base of e here because that natural logarithm. So from here we can just go straight to the calculator. All right, and so this time we're going to hit ln 4 in parentheses, and then we're going to divide that by 2. And we'll get this answer of 0.693. All right, on number 10, this was the first one that I mentioned that we do not have the exponential expression isolated. So we're going to just follow our basic rules of algebra, and we're going to subtract the 7 from both sides, which will give us this, and then we need to divide through by this 3 so that we can have the e to the x isolated. All right, so now number 1 on our steps is satisfied. The bases don't match on number 2, so we're going to try to rewrite. That's not going to work for this problem. So if we can't rewrite, then we're going to move down to step 3 and write it out in logarithmic form. All right, so again, if you're having a little bit of trouble identifying your b and your y, just write that form underneath of it, and that'll help you go into logarithmic form. So once we do that, it's going to look like the log base e 2/3 equals x. So once again here though, I've got log base e. So in order to put this into the calculator, anytime I have a logarithm that has the base of e, we're going to use the ln key. This is the natural logarithm. So when we go to the calculator, we'll hit ln 2/3 equals x. Now we can put it into the calculator just like this, or we could rewrite it as one of the properties of the logarithms, number 2 up here, which says that if you have a logarithm in a division problem, you can take the logarithm of the numerator, natural log of 2, you can subtract from that the natural log of 3, and you will also get the answer as well. All right, so plug this into the calculator. Natural log 2 divided by 3 in parentheses, and you'll get negative 0.405. Okay, or you could also put it in as that bottom as the difference of these two natural logarithms, and just so you can see, you would get the same answer there. Now, number 13 is a little bit unique in the fact that we have two exponential expressions, and so we can't really, they're both by themselves on either side of the equation, but we can't really do step 1 in terms of any algebra to isolate one over the other. They're both separated out on the right and left side of the equations. The great thing about it is if we look at number 2 where we say to check the bases actually match in these. So they both have a base of 3, and we're saying that they equal each other, these two exponential expressions. So if the bases match and the exponential expressions they're both in exponential expressions, then we know that those exponents have to match. The property for that actually looks like this: b to the x equals b to the y if, when we write this, when you see the if with two f's at the end, it means if and only if x equals y. So this number 13 falls into this pattern right here. So because of that, we can take those two exponents and we can set those two exponents equal to each other to solve this. So we take that negative 3x plus 1 and we set it equal to x minus 9. And all we do here then is our basic algebra to solve for x. So we'll end up with 4x on this side, 10 on this side, for an x of 10 fourths, or obviously reduced, we'd want to do that, so we'd have 5 halves. And that's it for that problem. When the bases match like that, then it becomes pretty easy, because all we have to do is take those two exponents, set them equal to each other. Now on that note, let's actually drop down to number 19 for a minute. We'll go back up to 16 after this, but on this problem, this is a great example. Once again, we've got our exponential expressions isolated on both sides, but we have 2 of them. Now here, though, the bases don't match. However, we can make those bases match. Since 9 is a power of 3, we can rewrite it as 3 squared. We can't forget about the 2 to the 2x. So instead of calling it 9 raised to the 2x power, we're going to call it 3 squared raised to the 2x power. The benefit that gives us then is that since the base over here is 3. Now our bases match, and we can do just like what we did up here in number 13 and use this property up here that says b to the x equals b to the y if and only if x equals y. That allows us to set those two exponents equal to each other and solve for x with a very simple algebraic equation. So right here, though, our exponent is 2 raised to the 2x power. So we need to multiply those two together and call it 4x. And then we would set that equal to 2x plus 4. And then we'd end up with x of 1/2. Oh, not 1/2, x of 2. Did my division wrong there. So on problems where you've got an exponential expression on both sides of the equation, look to see if the bases match. If they do, you're just going to set those exponents equal to each other and solve. If they don't match, look to see if you can make them match by rewriting one of them as a power. And if you can do that, then you can do the same thing and set the exponents equal to each other and solve for x. All right, so now let's go back up to 16. We have an exponential expression that is not isolated. So we want to get rid of the 4 here through division before we move on to the rest of it. Our bases do not match, and we cannot rewrite them to make them match. All right, so what that means, if rewriting to make them match is what we just did in number 19. If you can rewrite those as a power of a power. But we can't do that with e and this 1/4 over here. So then we're going to rewrite them, this expression, in logarithmic form. So that would be our log base e to the 1/4, I'm going to keep that in parentheses, equals 3x. All right, again, if you're having trouble doing that, take the b to the x equals y form and stick it underneath this problem right here and just follow along with your values from there. We have a log base e, so in order to put this into the calculator, we're going to have to rename that ln. So it'll be ln 1/4, and then we need to isolate that x by dividing through by 3. So I'm just going to go ahead and do that. All right, and so now we have our x isolated. Again, we don't have to do number 5. Number 5 is simply we're changing the base, using the change of base formula only if it's not already in base 10 or in base e. Because remember, we're trying to utilize the calculator, and then the log button utilizes base 10, the ln button utilizes base e. So we've already got it in the natural log form, so we're okay to go ahead and pull out the calculator. All right, so natural log, 1 divided by 4 in parentheses, and then we're going to divide that by 3. And we'll get this answer here, negative 0.462. All right, 2 more to go. I know this is a lot, so hang in there. All right, we'll go through our steps here. Our exponential expression is not isolated, so we're going to take care of that first by dividing through by that 3. And so now we have it isolated. The bases don't match, and we are not going to try to rewrite those to make them match because there's no perfect power going on here between the two. So we're going to rewrite it in log form. All right, if you want to, put your b to the x, y underneath here to help you transition into the log form. This one's a little bit crazier because of that there's a lot going on in this problem, especially with that fraction. And then once you get it into log form, you can see now that we have to go to number 4 and we've got to isolate x. X is not by itself right now. So in order to do that, we are going to need to subtract the 6 off of both sides. Minus 6. And so now we have our x isolated. Our bases, though, in our logarithmic function are 2. That's our base. So we've got log base 2 here. That's going to be a problem because we can't put it into the calculator with a base of 2. We need to either have a base of 10 or a base of e. So we're going to rewrite with a base of 10. So that means we need to come down here and use this change of base formula right here. If it helps you, take this side of the equation and place it underneath of this original formula right here, because then you'll be able to identify A and C a little bit better. We're going to make B 10, and so that's already taken care of. All right, so rewritten over here, this is going to look like log base of 10. I'm not going to write it because we assume it when it's not there, of A, which in this case is 17 thirds, and we're going to divide that by the log of 2. This 2 is my C value here. So 17 thirds was the fraction. That was A, and then my C was this 2 here. All right, I'm going to put this in parentheses because I want the calculator to do that first before it subtracts the 6 off. All right, so now we're ready for the calculator. All right, so when I put this into the calculator, I'm going to want to protect that 17 divided by 3 in parentheses. And then so it's log 17 divided by 3, end parentheses. I'm going to divide that by the log of 2, end parentheses there as well. And then I want it to subtract the 6. So make sure you're protecting well so that you're really telling the calculator exactly the order of operations you want it to follow. And there we get negative 3.497 as our final answer. All right, last one. We do not have our exponential expression isolated, so we're going to do that first by adding 8 to both sides. Then I want to get rid of this 3/4 coefficient by multiplying by 4/3. So we're just going to multiply by the reciprocal. And that will give me this right here. Okay, so I didn't show that, but hopefully 2 times 4 thirds, you know that to be 8 thirds. So now I have my exponential expression isolated. Number 2, bases don't match, but we can't rewrite them, so we go to number 3. We're going to rewrite in logarithmic form. So that would be log base e, 8 thirds equals 3x. Again, we've got this log base e, which we know that in order to use that in the calculator, we need to rename that the natural log. It's just another name for it. And then I need to isolate for x by dividing 3 by 3. All right, and then we're ready for the calculator. All right, and natural log, 8 divided by 3, end parentheses, and then we'll divide the whole thing by 3. And we'll get this answer 0.327 once we have rounded that 6 up. So I know this is a lot. Make sure if you haven't yet that you have written down these steps to solve it that are over here on the screen. You're going to need that in order to follow through each of the steps one by one as you do your homework assignment. So make sure you've got those recorded somewhere for you to utilize with that.